Hi, everyone. My name is Hermes Frangoudis. I'm Director of Developer Relations at Agora. And over the past year, I've built a number of different voice agents using Agora, OpenAI, 11 Labs, Cerebrus, Pinecone, a bunch of different really cool technologies. And I'm here to share with you 10 of the coolest lessons I learned and things that helped me along the way. So each project was kind of an experiment. Some worked out really well. Some broke in really hilarious ways. And every single one of them taught me something that I couldn't have learned from just looking it up online. So here's 10 lessons I kind of learned the hard way. For anyone not aware who Agora is, we are early pioneers in the real-time voice and video streaming space. We specialize in voice and video streaming infrastructure. So one-to-one, one-to-many, many-to-many, that sort of thing. If you want to have Google or Zoom or that sort of features in your app, that's what we do for you. But one of the things that we realized is while our platform is really good for human-to-human interaction, it's actually even better for human-to-AI interaction, where every packet has to make it. And if it doesn't, the conversation can go in a wildly different direction when it's misunderstood. So voice agents are, they're deceptively simple. You know, you think plug in the speech to text, add an LLM, get the text to speech, and we're done. It just works, right? Not really. And what I discovered is they're easy to build, but really hard to scale. So let me show you why. Before we get started, I do want to talk a little bit about visualizing what I call a cascading flow. So in voice AI, you have two models, an all-in-one and a cascading. All-in-one is just like the name says. I speak voice, audio comes out. A cascading breaks all those little pieces up. So you have your speech to text, and then it passes the data to your LLM then passes it to your text to speech. And this whole flow, Agora can do in about 650 milliseconds. So a little over half a second, but it gives you a really natural language and communication when you're speaking to an AI. So here's how it started. Back in October 2024, I know it's not 2025, but this was when OpenAI released their first beta of their real-time API. And the team, we were building different demos, and we built an integration where each of these blue dots basically represents a server instance. Each server instance could handle 3 or 4 users when they activate the agent or talking to it. Because unlike a traditional LLM, when this agent's talking to you, it's got to stay in the conversation. So it's not just responding and then leaving. So when it starts, you have to also be interacting with the same server instance to take it down, to turn it off. And one of the things we realized is a traditional load balancer, router, gateway wasn't going to work because they just load balance differently through round robin and things like that. But your start and stop requests would not be going to the same server. So when deploying something like this, you have to have multiple servers. You have to have this load balancer. So we had to build in our own custom little load balancer to make sure that all the start and stop requests went to the right instances and the right agents were leaving. And in that process, something I noticed that people at the time were telling me I was crazy, but recently one of the VPs of research from DeepGram confirmed it. The voice out is not always equal to the text out. So in JavaScript, you have the triple equal sign. It's not even a double equal sign on this one. Like the text is just different to the point where you can't trust it, and it's so black box and because it's a voice to voice. So that was a very interesting takeaway. It's all right, I'm hearing this audio, but I'm getting different text in the transcript, which doesn't really work if you're trying to audit these things later on. Wait, we have 2 different things that don't reconcile, and the user's experiencing 2 different things. So after that, one of the next projects I got to build was with Agora's conversational AI engine. I got an early preview of it in February, and the really cool thing is all I had to do was build the front end. To get started, I pulled up the voice demo from Agora plugged in my details, like the app ID and token, and then used just like a curl request to invite this thing into the channel, and it just starts talking to you. I didn't set up any infrastructure. I didn't set up anything other than this like post request to the back end, which was really cool. So from there, I then built a whole UI where like it shows you the visuals and stuff like that. And this was kind of like my first end-to-end agent, and it was really amazing to see the cascading flow and how much faster it was than the OpenAI like all in one. Because the OpenAI one was using like WebSockets, and this used UDP. So in terms of the data transmission, you didn't have all those handshakes and the checks to make sure that the data came back. The reason I bring up WebSockets and UDP and stuff like that is because my next project that I got to work on was mid-February. 11 Labs had a hackathon where they had just released their conversational AI, and they were getting people to like build with it. And I thought, man, this is really cool. Looking at their API, it had similar WebSocket type interface to the stuff we had just done with OpenAI. And I was like, all right, I could do this. Sat by myself for a weekend in their New York office, basically taking the Python demo that we had for Agora and OpenAI and rewriting it to work with the 11 Labs interface. Load balancers, everything still had to be the same because at the time they didn't have a WebRTC interface, so it was all WebSockets. I deploy this thing, and one of the things I realized is they're using a cascading model. It's not all in one. So as I'm talking to it, there's like visible delay, like lag in the time that it's speaking, and sometimes it'll like pause and then like keep speaking. It was very interesting to say the least. And what it made me realize is like WebSockets can't be part of the equation. They're just too laggy in that sense of communication. There's too much checks and like, oh, did you get that? Nope. Let me retransmit from the beginning, right? Whereas UDP, you just drop the frames. In general, it was like a really interesting project. I really learned that latency and flow matter. One of the things, because it was a hackathon, I didn't get to put the interruption detection in there. So I'd talk to it, I'd ask it a question, and just start talking. It's like your 3-year-old when you ask them a question, and you can't even like respond. That's kind of what it felt like. It was very interesting. And it made me really appreciate the fact that we have that turn detection. So my next agent project really came about as more of like a fun thing. So as I'm building these agents, testing Agora stuff, like my kids are coming to my office because I work from home, and they see me talking to the computer. First, they thought it was hilarious. Then they started talking to the computer, and I was like, man, this is not safe. Like the interface is really frictionless, but you can't just let a child talk to an AI like unfiltered. So I'm talking to a buddy of mine who's also real big into AI, and he's liking the voice stuff. It's like, wouldn't it be cool if we just had a voice-to-voice AI that had some like simple guardrails on it, and you could hand the phone to your kid? So in a weekend, we built the UI, and because it's running on Agora conversational AI, there's no back-end infrastructure that I have to launch. And this thing is awesome. After dinner, I'm like, hey, finish your dinner. You talk to Beepo for 20 minutes. And they just ask it all sorts of wild questions. They'll even ask it, hey, make me a story about a carrot, a broccoli, and a chicken. And the thing will just pick up and go, and you can interact with it. It's really cool. I'm going to try to do a demo of Beepo probably at the end. So let me get through. But the one big lesson I learned here is the prompt makes all the difference, and use AI to help you generate the prompt. Because I noticed that the prompt that I got out of OpenAI is almost impossible to jailbreak. Like some of my coworkers were playing with this thing for 2 hours, trying to get it to like say inappropriate stuff and speak about inappropriate things, and they just couldn't get it because of that prompt. And I realized how strong a difference the prompt makes. The next project came in May. We're doing a product video for Agora's conversational AI engine, but it's all code. And so you can't really show a screen of like me typing code and stuff. Like it doesn't come across very interesting. So taking some inspiration from 11 Labs, I saw their UI for their conversational AI, and I was like, I can rebuild this all with Agora technology. Thank you, V0, for the UI. But yeah, so you log in, you can click create a new agent, and basically it stores this data in JSON. So when you hit test, it sends it over to the API endpoint, triggering that agent. And it was really fun because we could switch between agents and different prompts, and you could really show the flexibility of it between here, this is what it sounds like with this TTS and that STT provider, and you could really customize and play around. I also included Agora's cloud recording for the audio recordings and our real-time transcription, thinking, you know what, if you're testing these things out, it'd be great to have an audit of it, because like every conversation, it's really hard to track, especially if you're finding bugs, right? Like you need to know the agent ID, you need to know all these details because these things are done at hyperscale. So it's like finding a needle in a haystack. And it was a fun little project. It took me about a month. And what I got out of it is it's really cool to see all these agents and like being able to customize them. But when you go straight to the model like this, it doesn't really do anything other than talk back. So my next project was to build an agent that could do something, right? And I travel a lot, so I was thinking it'd be really cool if I could have a conversational AI that was like my local guide. I was like, all right, let's start with a long context. I travel a lot to San Francisco, so I used the Yelp API, pulled down a bunch of restaurant details about restaurants in San Francisco, put it into a JSON, and then included that JSON as part of the prompt. Interestingly enough, it completely hallucinated most of the data in there. The longer the prompt, the more likely the AI is to hallucinate like what you're expecting. So that was kind of a bummer, because it was like, oh man, if I could just like stuff it all into the context window, Google Gemini, we're great. Not so simple. So taking this one to the next level, create a new endpoint, did it with RAG. Using Pinecone, stored all the data in a vector DB, had my own LLM in there. So as the data came through, I sent it to Pinecone first, got the relevant restaurant information, then passed that all to the LLM. Boy, was that good. That was really responsive. It was really good, really accurate on the data. Problem was, all I had was San Francisco. So like the RAG is only as good as the data you can hold in it. It's not like live data, so you constantly have to update the RAG and maintain the RAG, and that's kind of a bummer. So going back to the drawing board, next time around, I'm like, all right, rather than RAG, we're gonna go straight to the API. So using their API, I wrapped it in some functions, started doing function calling. Very interestingly, you cannot use text streaming when using function calling. You have to use full response, because as it's streaming out, it has to know what the function call is to be able to trigger it. Some of the newer models are better at this, but at the time I was using Cerebras and it just wouldn't allow me. So that was kind of a bummer, because you don't get that really cool stream effect. Like there's visible delays in this thing's taking all the output, sending it to the model, executing a function. And that was the other fun part. After you execute the function, you can't just pass back the response to the user. Like I don't need to see a JSON. I need to hear natural response. So then it got into, oh, all right, when you do a function call, now you have to reprompt before you return. So you take the response from the function call and you put it into the context and then just send it right back to the LLM. And that was quite amazing. I was like, whoa, this is cool, because you could ask it for like, what's the best pizza in Morristown, New Jersey, which is where I'm from. And it would give me a place. I'm like, I don't know if that's really that good, but according to Yelp, it's great. So, huh? Yeah, we need an update there. So, a couple learnings. Streaming doesn't work with the function calling. The output from your function call needs to be reprompted, and then the prompts really must be clear. Because one of the things I noticed is like if you don't have really good examples of what those function call structures look like, it'll hallucinate the function call, and then it'll repeat that back to you. So you get like, I don't even know how to describe the response. It's like hilariously bad. It's like trying to read a function out. So it's interesting when it malforms. And like I've heard of this before, like certain models are better at function calling. And I didn't understand what that meant. What that means is when it tries to put out what it needs to trigger the function call, it doesn't get that request right. And so it doesn't actually call the function, it just tells you what it thinks it should have done. So now that I had a Yelp agent that could look up data for me, that's cool, right? But doesn't really do much more than be a useful kind of assistant, which is the same as just talking to it. So my next project was, how can I get this thing to order me dinner? And that was an interesting one. I was like, we have this PSTN technology. For anyone that's not familiar, PSTN is how you connect traditional telephones to voice over IP and like real-time streams and stuff like that. So some of our team members had built a PSTN server that I was able to tap into and use their phone number. So using, again, just a RESTful API call, I could trigger another bot that dials out. So using this, I was triggering phone calls within the same chat. I'd be like, here, order me dinner from this place. This is what I want. Make it pick up. The connection would join. I could see the other voice in the chat. I could hear myself because I was calling myself. But funny enough, the AI would look at that as a new person and just start over fresh. Be like, hey, how can I help you? And it's like, well, you called me. How can I help you, right? Yeah, exactly. And then you go, but you called me. How can I help you? Oh, I think there must be some confusion. I'm your local friendly AI guide. And it's like, wait, that's not what a restaurant should be hearing, right? So that's very off-putting for the person. So thinking about the solution, I was like, how can we adjust it? Try to doing it through the prompt, kept going terribly wrong. In some instances, it would like start well, but then the person would speak, or I would speak. It'd like catch both the audios. It was very awkward. So the revelation, I guess, or what I've found out as a solution is multi-agent. So I have one agent. They control the ability to get all the order, collect all the details they need to. But then I wrote a function call that uses Agora conversational AI that makes post requests. So no backend, like I can launch infinite ones of these. And in that second agent, it's part of their system prompt what I want to order. You're this agent, you're calling this place, you're ordering this food for so-and-so, pickup, delivery, whatever, has all the details right there. So when it would call, it'd be like, hello, so-and-so pizza. Hey, I'm placing an order for delivery. Okay, what's the name? This is for so-and-so. Where's it going? And it would actually respond. I shared this demo internally. Funny enough, I forgot to take my phone number out of there. So I had at 4 a.m., I can probably see it still. A bunch of voicemails from an AI agent that are just like 30 seconds to 3 minutes long of it speaking orders to me. So that's another lesson I learned the hard way is if you are using PSTN, do not hard code your phone number into the demo. So if you'd like to try the Agora conversational AI engine demo, here's a quick link. Give you guys a couple seconds, take some photos. I got some more QR codes, so we'll keep going. Cool. Nice. All right, next one. So if you want to start building, here's some more examples, quick start guide, that sort of thing. And while you guys are doing that, I'll spin up Beepo. So let's see if we get this rolling. Sorry, the PWA is not being friendly. Let's see if the Wi-Fi lets me do it here. Sorry, guys. Looks like my Beepo demo is not working. The Wi-Fi is not happy with me. So if you want to see Beepo, I will gladly demo it after. I have about 5 minutes left. I know we're not really allowed Q&A. So I do want to thank everyone for their time. Cool.